Let's come back to this example of specifying the constructors to call. So remember when we had the car and we had two constructors, one taking an engine and a log and the other taking the engine, we specified that we wanted the engine-only constructor by specifying the appropriate using constructor. Now I'm going to get rid of this for now, and we'll take a look at something slightly different, and that is the similar situation for using an engine. So we'll revert back to a situation where all of the components were done automatically for us, and let's talk about the engine. Now let us suppose that for testing purposes I want the engine to have a specific ID number. Now there are different ways of doing it. One way is registering an instance like we showed previously. So you would say something like var engine equals new engine, where you would specify the log, and here you can say, for example, new console log, and you would specify the actual integer value, and then you would say builder.register instance. So that is one approach. Another approach is to let the builder resolve the types. So keep registering the types. However, when it comes to instantiation, you specify explicitly which constructor to call, but you specify it as a lambda. And that way we can specify exactly what parameter gets passed into the constructor. So let me show you how this works. So instead of registering type for the engine like this, we'll do it differently. So let's define it as follows. So I'll say builder.register. But here I'm going to do something different. Instead of providing a generic argument, I'll have the opening round bracket. And one of the things you can do here, as you can see on the screen, is to provide delegates which actually instantiate a particular type. So in this case, I can say C goes to new engine, where we specify the log and the ID. Now something very interesting is happening here, because the type of argument of the lambda that we're providing, if I just go ahead and I insert the entire signature, is iComponent context. Now this is a very interesting argument, because when you specify a log here, and an engine does need a logging interface, you specify it not by making a new console log or whatever, but by still using the container. And you access the container through the iComponent context. So here, the iComponent context can be used to specify that whenever somebody is constructing an engine, whenever somebody requested an engine to be made or injected into some component, the logging interface is still taken from the component. So let me show you how this is done. You take the component context C and you say C.resolve, and here you specify ilog, and that is the second argument. Now the second argument is what we wanted to specify in terms of the ID of the engine. So here we can specify 123 as the engine ID, for example. So let's just recap what we did. Instead of just registering an engine to be injected automatically, because the engine has a constructor which takes an integer, as you can see here, and we certainly don't want to specify a default integer for all components. That would be silly. We specify a lambda which takes an iComponent context, and it creates a new engine where the log is still created from that component by calling resolve, by using the component context, and the second argument is provided manually. So now whenever somebody actually tries to make a car, for example, it will get injected a new engine where the type of log is going to be taken from the container, but the second argument, the ID, is going to be 123. So let's execute this and see what we get. And as you can see, that's exactly what we wanted. So we're getting engine with the ID of 123 going ahead 100, and then the car going forward as before.